At the end of the lesson, you are expected to identify generalization and overfitting, relate generalization to overfitting, and appreciate generalization and overfitting in mastering machine learning algorithm. Okay, still we are going to use our former example, and remember that our aim before was to accurately predict our sales performance. Still remember in our past lesson, so I'm going to put the link in the description below so you can just go back and understand what our former example was, because this really helps you a lot in understanding what this lesson is all about. Okay, so with this, we considered 8 degrees of freedom. So when we say degrees of freedom, it has something to do with parameters or the number of coefficients or the number of features or variables that we use in a certain set of data. So for example, our degrees of freedom are, we have age, gender, profession, the average income, the marital status, addresses, we have the items usually purchased, and the amount usually paid. So considering these 8 degrees of freedom, we're going to make a prediction. So anyway, let me write first degrees of freedom so you can properly see. Okay, degrees of freedom. Okay, right. So again, as what I've said, we have 8 degrees of freedom. So we're going to use these 8 parameters to make our possible predictive model. Okay, so granting that we are already done with it, so this is our predictive model. So we have here y is equal to the function of f with x having the attributes s1 to s8 and with parameters w0 to w9. So before in our past lesson, we talked about why we have a w0 to w9. So we said that w0 is our intercept and w1 to w9 are our gradient, right? So we have here w0 plus w1x plus w2 s1 dot 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 going to w9 s8. Okay, so before we continue, please hit that subscribe button to enjoy more our deep learning, machine learning, and natural language processing lessons. So click the notification bell to receive more updates. So using this data or this model, we have here now our model or our plot for our training model. Okay, so as you could see, we have a point from here and then it goes down, and then we could see here a broken line. So later we will have that. Okay, so but first and foremost, let me ask you this question. So what do you observe in the direction of our line? So with that, please reserve your answer for later. So we will be doing that as we go along with our discussion. So at this moment, it is worthwhile to mention the main purpose of building a model. So basically the reason for this is that this is our guide. Let me write here. A model is our guide as to the steps we are going to take in building and adjusting our model. And maybe you would like to ask me, sir, what is the aim of this then? So basically the aim of making a model is to make the best model that can make the most generalized predictions. Okay, maybe at this point I think it's better to tell you or to discuss to you what we say when we say most generalized prediction. So when we say generalized prediction, it means that our model can be applied even beyond, this is the keyword here, even beyond the training set that we already have. Okay, So if only we are too idealistic in making our model, we want something that can give the best performance, of course. Who would ever want something that is not the best, right? Of course, aiming for having the best model really can save our time, of course. Time, money, especially when we are dealing with stocks, and of course our resources, okay? Because we are going to use different infrastructures just for, like, for example, storing the data. And what if what we've stored is a wrong one? So we're going to uh, reformat that one again, right? So now, again, the aim for this is that we're going to make the best model that can predict a certain performance. Okay, so to understand all of these, let's go back to our plot. Okay, let's have this one again. So examining this plot, we are warned as early at this stage to be too cautious. And in fact, we must redo our model. Okay, again, let me repeat that because that's really very important. At this very stage, upon seeing this kind of model, you are already warned. This gives us a warning what to do. It could be that we're going to redo our model. See? So this makes us really very cautious. So does this make sense to you? Okay, I know that something is going on in your mind, and maybe you would want to ask me, why are we warned at this very early stage of the process? So what is the status of our model then if we are warned? Okay, well, we have to be very suspicious looking at this one, and then we see this broken line that's going up. So what do this mean? So the continuous broken line, this one, is our training set. Okay, let me divide. So from here, the one that you could see, okay, this is part of our test set, and this is a part of our training or sample training. Okay, just for clarity and your eyes would not be confused of what you could see here. Okay, so although so the broken line is our test set. So let's remember that we use an 8th order polynomial in our training set. Remember that we said we are using here 8 attributes or features or parameters. Okay, so it means to say that we are using an 8th order polynomial. So it shows that the loss is from this point going to this point. It means that the loss is decreasing if we're going to use the training set that we have. Okay, so seeing that this loss is decreasing, then we feel so happy. It's because we could say that we are, or we've made the perfect model. Then we have a very good performance result for our prediction. But the question is that what's going on in here? So this is the moment when you apply your model to your test set, and then you could see this broken line. So what it means here is that the loss is going up. So if we're going to compare them, then we could see that the result is contrasting. That's why we are alarmed and we have to be very cautious. So although at this instance it can be seen that the test may follow the same trajectory from this point going to this point, okay? But when it reaches this point, it changes its direction going upward, okay? So it means to say that as we add more data, the outcomes become less and less accurate. Okay, I think I have to repeat this one. So when you apply your model, maybe at the very first instant, it could be that you could see something is really doing well because it follows some kind of the same direction. But then when it reaches this point, we could see the difference, and then it starts to go up, because most often if we're going to add more attributes, then we have more parameters, then we could see in there more results, more differences in the movement of our line. So does this model make the best prediction? So obviously it does not. So using the 8 attributes overfit the training data. So it means that okay, it overfits. Okay, from this point going to this point, we could see that using the 8 attributes overfits the training data because it puts too much attention on it. Okay, so therefore it cannot and will not generalize well to our future data. Okay, so it means that if we're going to apply this one to the data that we have for the test or the testing process, then we could see that something is really wrong. So because this really overfits the training data, and it can never be applied to the test data because it will disregard the properties, because the training model only focuses on the data in here. So what would be our take on this kind of result? So our take on this is that the more and more attributes we use, the closer we get to the training data here in this case. So only with respect to this situation, the prediction is good from here and here. See, the prediction is good. So outside this, the prediction becomes very poor, and the more we add more data, we could see that the result deteriorates so fast. So does it mean that we have, or that we always have to resort to simplicity, because seeing that we have here 9 or 8 attributes, then we could see that there is really overfit? Okay, so that is actually a very good question, but the answer is no, not necessarily, because by resorting to this, you can be prone to underfitting. Okay, that means if you're going to only have 1 or 2, it could be that the model will still underfit. Having more and more, it could be that we have an overfit. So with this, it is very necessary to understand how to make bias variance trade-off, which we will have in our future lessons. What is this for? Why do we have to study this? Our understanding of generalization and overfitting helps us explore, analyze, and leverage our data. After all being said and done, let's try this. What is overfitting? What is generalization? How do you relate overfitting to generalization? And why do we have to understand overfitting and generalization? Please leave your answers down in the comment so that we would be able to learn from each other, and our interaction would be more meaningful and richer. Do you know, or do you want to know more about this course? Just click the card on your right screen. You can enjoy our deep learning, mastering machine learning algorithm, and natural language processing courses. Learn and upskill for free.